Good morning. Today we're going to try rotting oranges. Appetizing. You are given an m by n grid where each cell can have one of three values. Empty cell, 1 is a fresh orange or 2 is a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. Okay. So let's check the constraints. M is grid length, N is grid I.length, and M is up to a 10x grid. M and N is 1 to 10. Grid IJ is either 0, 1, or 2. Okay, any edge cases I can think of. There's obviously the edge case that it's impossible, so that would be like this grid where you can't get to one of the oranges. Orange not adjacent to rotting orange. Okay, so let's do a grid. So there's the example that they have right there. And then there's this second example where we have a good orange or a rotten orange. And a good orange. What do we have? 2, 1, 1, then 0, 1, 1, and then 1, 0, 1. So this one is safe because it doesn't have any 4 directional adjacents. Now, if we do a grid similar to the first, if we put this one here and this one here, now what if this starts off as a 2? Then this becomes a 2, this becomes a 2, and this becomes a 2. And then that's a 2 and that's a 2. So I think that I need to loop over every rotten orange. If the orange is rotten, then I don't need to check again. Which means first I have to find all the rotten oranges. I know all it's giving me is the grid. All I get is the grid, which means I have to find which oranges are rotten. So I'll go through the entire grid, checking which ones are rotten. And putting them on a on a queue. And then I repeatedly loop over the queue. If there's a change made, then I increment the minutes. And or I break the loop. If I counted any good oranges, maybe I should store a count of good oranges after I loop it over first time. So count of good oranges queue of rotten oranges if I change a good orange then I want to decrement good oranges. And add the current orange to the queue. And I also need a set of visited oranges. Do I though? Yeah. If it's a visited orange, I can still change it, though I shouldn't need to. But I don't want to add it to the queue. Else break. Okay. So we'll start coding with count equals 0, visited equals set, and queue equals simple queue. We'll need to import that from queue, import simple queue. Okay. So, first I need to loop over the whole list for row and grid, for column and row, if grid row column equals 2, then q dot put no weight. And we're going to go row column. If grid equal grid row column equals 1, count plus equals 1. Let's change count to good count. Okay. So that's just building the details we need. We also need rounds, minutes. Minutes equals 0. Okay. Then while q dot size greater than 0, and we're going to go go rot to spread. That's descriptive. Equals q dot size. Yeah. For blank in range q dot size let's see, I think we need to do another directions object. Directions is a tuple of tuples, and we have -1, 0, and 0, -1, and 1, 0, and 0, 1. So for blank in range, q size, for direction and directions, if direction adjacent orange, adjacent cell equals current rot equals q dot get no weight. And adjacent cell equals direction 0 plus current rot 0 direction 1 plus current rot 1 . if 0 less than, let's define m and n up here, m equals length of grid, n equals length of grid 0, that way I can do adjacent cell 0 less than m and less than adjacent cell 1 less than n. So if it's a valid direction and grid adjacent cell 0, adjacent cell 1 is equal to 1. So if it's valid and there's a good orange there, then we're going to make it a bad orange. Equals 2. In which case we decrement the count. Grid count minus equals 1. And then we add the adjacent cell to visited. Adjacent cell is already a tuple, so that's good. And we're going to add it to Q. Q.put, no weight. Adjacent cell. Okay. And that's all for that loop. All we do is pick a direction. If it's a good orange, we change a bunch of things. If it's rotten, nothing else matters. If it's empty, nothing else matters. Okay, so current rot gets some directions, does all those things, goes back. We get through all of the size for that leg of the queue, and then we need to flag if something was changed. New rot equals false. And here, new rot equals true. So if new rot then we're going to do minutes plus equals 1. And this is queue size greater than 0 and new rot. Okay. I changed a good orange. Yeah, that else break isn't what happens. It's not absolutely clear based on this what I was getting at, but it's basically correct. Okay, so is that all there is to it? As long as we're changing stuff, we're continuing to expand. Okay, so here, if good count is greater than 0, return -1. Otherwise, return minutes. Right. I got a runtime error. Did I forget a comma? Probably. Yep. Forgot comma. List indices must be integers. Line 19. For row. Yeah, I need the index, not the row itself. So we'll do range grid, range length grid. Try again. This is type int has no length. Naturally. Yes, I meant queue size, which means I meant queue size, and I haven't actually defined new rot yet. Okay, got a wrong answer here. It outputs -1 on this one. Let's go. I am currently adjusting the cells, although I probably don't need to. But since I am, I'll just print a grid at the end. Run. According to this, I'm not finding anything. Let's go. Print good count. Okay, so we're starting with 2. Oh, good count and print Q. Q.Q size. Let's go here and print Q.Q size. So it's not actually getting in here, even though Q size. Q size is 0. That's not right. Print column row. Right. It never did 0, 0. Why is that? That's a really strange thing. For row and range. Was I supposed to do no? For row column, range n, should start at 0, 0. Object has no attribute size. Where did I? Oh, there. Okay. So we get down here with queue size. Good count queue size. Then we get here to queue size. For blank and range queue size. And then here let's print current rot. And then if everything, oops, let's go print adjacent cell and print true. Okay, so we start off, we find adjacent cell 0, 0, 0. Oh no, current rot is 0. So adjacent cell is -1, 0. Ah. There we go. Right, none of those, this should have been true. Okay. Perfect. Yeah, it had a problem because I was skipping 0 on my check. So, now we go through and comment out print statements. Good. And then we'll submit. Boom. Very poor speed. Definitely can be improved. I think I already know an opportunity or two. But got it on the first try. Thanks for joining me.